Hi, welcome back. Today we're going to be looking at related rates, but more specifically at ladder problems. So what most of these problems look like is you have maybe a house or some other structure that a ladder may be rested upon, and you have a ladder, let's say like this. Let's say this is a ladder, but only one of these lines is relevant, because if you're looking at a ladder directly from the side, you're just going to see its side profile, which is just a line. So for the sake of making this easier to understand, I'll just draw that one line. So you have a ladder on the side of a house, and the bottom of the house and the ground make a 90-degree angle, and it connects with the bottom of the ladder and the top of the ladder to make a 90-degree triangle with its respective sides. And the ladder will usually be sliding down the house, so the side length B will be decreasing, and the side length A will be increasing. It'll be getting longer. So dA dt will be positive. Usually dB dt will be negative. But the point of the problem is to find what something is equal to, or what some rate of change is equal to, as the ladder slides down, but obviously the length of the ladder remains constant. So let's look at one of these problems. So I got this sample problem from the University of Colorado Boulder. So in this problem, an 8-foot long ladder is leaning against a wall. So let's draw our wall. Let's draw our wall, and let's draw our ladder. So the ladder remains at a constant length. It's always 8 feet long. So we can just write 8 for this side because it's constant. The top of the ladder is sliding down the wall, like I said it usually would be. So it's sliding down the wall. We'll call this side Y and this bottom side X. So the ladder is sliding down the wall. So this tip of the ladder is sliding down the wall at a rate of 2 feet per second. So dy over dt equals -2, because it's decreasing at a rate of 2 feet per second. It's getting smaller at a rate of 2 feet per second. So how fast is the bottom of the ladder? So dx dt, because how fast is the bottom of the ladder moving along the ground? So what's the rate of change of x when the bottom of the ladder is 4 feet from the wall? So when this equals question mark, when x equals 4, because the bottom of the ladder is 4 feet from the wall. So here's what we want to do first. We want to think about what's an equation that relates these three variables. That would be the Pythagorean theorem. So x squared plus y squared equals 8 squared. So now that we have this equation that relates all of our variables, we take the derivative of it. So the derivative of x squared, is 2x dx dt, because we're differentiating with respect to time, plus 2y dy dt, and then the derivative of 8 squared, because it's a constant, is just 0. So now what we can do is plug in all of our values to find what we need to find, which is dx dt. So 2 times x, which is 4, times dx dt, plus 2 times y, which we don't know what y is. We haven't found y yet. That's still needed. So immediately when we are going to plug in and we find something we don't have, we have to look back to the information we have in the equation, or in the picture and equations we have, to find out if we can somehow find this variable. And in this case we can, because we can use the Pythagorean theorem. So x squared plus y squared equals 8 squared, and plug in what we know about x. So we know that x in this case is equal to 4. So 4 squared plus y squared equals 8 squared. So that means y squared equals 8 squared minus 4 squared. So therefore y equals the root of 8 squared minus 4 squared. And then you can simplify that. So now we have what y equals, that being square root of 48. And we can plug it in to our differentiated equation. So now we have 2 times what we just found, square root of 48, times dy dt, and it told us dy dt is -2, so times -2 equals, I don't have a lot of space here, equals 0. Okay, so now all we have to do is isolate dx dt to get our answer. So to do that, we will just flip this to the other side. So it's positive, make it negative. -2 times root 48 times -2 divided by 2 times 4, which is 8, because we have to divide by 8 to isolate this dx dt. And then finally, let's find our units of measurement and time. So I see there's feet, and I see feet per second. So feet and second. So this would be feet per second. And that would be our final answer.